Check out this problem. Find the average rate of change. Stop right there. What's an average rate of change? It's the slope between 2 points of that function on the interval from -1 to 2. Okay, I think I can do that. I believe I can. So what I'm going to do is use a pencil actually, because this may not turn out well if I use an ink pen. And I'm going to connect the points at 1, and -1 and at 2. I want to connect them and I want to see what that slope is as I bump the camera. I hope you realize what's happening here. Turn this sideways for a second. Hope you realize what's happening here in terms of vocabulary. I just drew a secant line. This is a line that connects 2 points on a graph. Now, you can say, well, what about that third point? Well, yeah, it does happen to cross a third time. But the slope that I have defined, the line that is defined by these 2 points. That's just a coincidence that it happened to hit again, okay? It just happens sometimes. But I was focusing on these 2 points, created that line, and I want to know the average rate of change. The average rate of change is, well, a rate of change. A rate of change is slope. So up at the very top, we could have put rate of change. I think that's a good idea. I'm going to back up and put rate of change. We've got lots of things going on here. Rate of change on its most fundamental level, that's one of the things that we could say slope is. It's rise over run, it's change of y over change in x, represented a couple different ways. It's also a rate of change. So the slope of this line, you can see it. You do the rise over run thing, and you're going to have down 1 over 1, down 1 over 1. You're going to have -1. So let's just go ahead and write that as an answer. I'll write it in red. We'll put it over there. If you wanted to, if you're really into this sort of thing, you could find y2 minus y1 over x2 minus x1. You could do that, and this will lead you to the exact same place. So f of 2 is 0, f of -1 is 3, 2 minus -1 is +3, and that gives me -1. Okay, same thing. It's going to give you the same thing either way. I just wanted to show you graphically what it looks like and algebraically what it looks like. So using the same function, estimate the slope of the line tangent to the curve. Tangent to what? Okay, vocabulary time. It's the line that represents the slope of a graph at 1 point. So I want to have the slope, I want to draw a line at -1, at +1, at x equals 1. And it's going to be right there. And I'm going to show you what not to do. What I'm not going to do, and if I had a ruler, I could do this a little bit better, but I don't have one with me. I'm going to use a paperclip instead. Here's what the slope is not. It's not that, okay? That doesn't represent the slope. Okay, so let's think about slope of a curve. Let's actually use words like increasing and decreasing. Well, my graph is increasing. My graph is decreasing. My graph is increasing, right? So the slope over here, at any given point over here, it would be positive. So if I was to just have some little line that just follows along some general slope known as a tangent line, then the slope of that line would be positive, and then actually up there it's going to be 0. That's going to come in very handy later. And then it's going to come down, and that's going to be a negative slope, and then 0, and then positive. So I'm estimating, this is just an estimate. I am going to give you the exact answer, which we will learn how to find soon. But for now, we're just kind of whetting our appetite with a little bit of vocabulary. And that vocabulary has to do with the tangent line in this case. I want to draw a line that is tangent to this curve, not quite at the bottom, so not horizontal, but it's sort of negative. It's just kind of like that. Now, I'm aiming because I know what the answer is. The answer that you will learn how to find later is actually -1/2. But if I drew a little tangent line right there, and you can put little arrows and it goes on forever, like all lines are supposed to. If I drew a little line right there, the slope of that line would be -1/2. So if you're like, man, I would not have gotten -1/2. I would have had it tilted slightly differently. No, don't worry about the exactness of it. That's not the point at the moment. All we're looking for is just a line. Can you draw a line that looks like it follows the general contour of this this curve at that point, and you might have had it down here just because you might have eyeballed it wrong. Not a big deal yet. We're going to work on the specifics later.